Hello everyone, my name is Dr. Uminde and I'm going to continue with the lecture series on development of the heart. So we had talked about the endocardial tubes and how they fuse and form the primary heart tube with the four parts and the dextral looping occurring. Then we now had to partition the heart. We started by partitioning to form atrioventricular canals. If you can remember, there's the chamber of the heart, the ventral endocardial cushion, and the dorsal. They come towards each other, fuse, and separate now this chamber into two: a right atrioventricular canal and a left atrioventricular canal. But above the endocardial cushion, the atria on the right and left side are communicating. So we need to partition the atria. Then below it, the ventricles are communicating. We will have to partition the ventricles. So now we are discussing partitioning of the atria. And we said that from the roof of the developing heart, there's a septum that grows downwards. That's the primary septum. It's the first one. That is the septum primum. And it goes and grows towards the endocardial cushion. But before it gets to the endocardial cushion, there's a space. That's the ostium or foramen primum. So it keeps growing to get to the endocardial cushion. Before it approximates the endocardial cushion, apoptosis starts occurring on the upper portion to form an ostium or foramen secundum, a secondary ostium. And the secondary ostium will be guarded by a septum secundum, a secondary septum that develops on the right side of this foramen that is forming. So there's a downgrowth, which is septum primum, primary septum, and space between the leading edge of the septum primum and the endocardial cushion will form a foramen primum or ostium primum. Then the septum primum goes down and fuses with the fused atrioventricular cushion. When the septum primum is ready to fuse with the endocardial cushion, what happens? Apoptosis occurs on the upper part. Multiple perforations develop on the cephalic part of the septum primum. And these perforations, they coalesce and form a huge foramen. And this is an interatrial foramen, which we call the foramen secundum. And this foramen secundum ensures the continuity between the right and the left atrium. And it's guarded by the septum secundum. Septum secundum actually is a downgrowth from the roof, and it forms on the right of the septum primum. So then it grows from dorsal to ventral, therefore forming what we call the foramen ovale. Foramen ovale usually allows most blood that enters the right atrium through the inferior vena cava to be shunted to the left atrium. So remember, the blood that is coming to the right atrium through the inferior vena cava, it's oxygenated, because it has been brought to the inferior vena cava by the umbilical vein into the foramen of right atria through the foramen ovale into the left atrium. So these two septa, they act as one-way valve. The septum primum and secundum act as one-way valve. Therefore, blood only flows from the right atrium to the left atrium. So blood can only flow this way. Okay. So this is the endocardial cushion and septum primum, ostium primum. Okay, as the septum primum grows towards the endocardial cushion before it joins it, apoptosis begins. It forms perforations up here. Perforations coalesce to form ostium secundum, which is guarded by septum secundum, that is a downgrowth on the right of the ostium. Okay, and eventually it forms the foramen ovale, and this allows blood from right atrium to left atrium only. It doesn't allow unidirectional blood flow. Okay, so that's the foramen ovale. Okay, so blood can only come this way. Then so that's the ostium primum. That's the ostium secundum. So this is septum primum, ostium primum, septum primum, endocardial cushion here, septum secundum. That's your ostium secundum, and this is your foramen ovale there. Okay, so it only allows blood from the right atrium to the left. If blood is coming from left to right, it will close and will not allow the flow in the other direction. So the blood flow comes from the vena cava to the right atrium, but majority of it does not go to the right ventricle. Remember, we don't want blood to go to the right ventricle, not most of it, because usually the heart pumps from the right ventricle to the lungs, but the lungs are not developed in utero, so we need to bypass the lungs. So most blood now uses foramen ovale to enter into left atrium into the left ventricle. So basically that's what happens in the partition of the atria, and that's the foramen ovale here. Okay, so this is the septum primum, the septum secundum, that's your foramen ovale. So what happens? There are changes that will occur in the sinus venosus and the associated veins. So initially the sinus venosus will open into the center of the primitive atrium, okay? And we have right and left horns of equal sizes. So the right anterior cardinal and right common cardinal veins, they form the superior vena cava. Then the left horn of sinus venosus usually forms the coronary sinus. The right horn enlarges and receives all the blood from the embryo and the placenta. So sinus venosus generally and the right horn are incorporated into the atrium, and that's what forms the sinus venarum, which is a smooth part of the right atrium. Okay. Remember, our heart tube had bulbous cordis, truncus arteriosus, bulbous cordis, primitive atria, primitive ventricle, and sinus venosus. So the sinus venosus opens into the primitive atrium. Then we have the right and the left horns of equal sizes. So the right, each of the horns has cardinal veins, vitelline veins, and umbilical veins. So the right anterior and common cardinal veins join to form the superior vena cava, while the left horn of the sinus venosus becomes the coronary sinus. So what happens? The right horn actually enlarges and receives all the blood from the embryo and the placenta. So usually the sinus venosus and the right horn will become incorporated into the right atrium and form the sinus venarum, which is the smooth part of the right atrium. So in the 4th week, blood is received from both right and left sinus horns, okay? And you can see you have this sinus horn here and this one, and each of them has a vitelline vein, then cardinal veins, and yeah, vitelline vein, cardinal veins, and umbilical vein. So this is umbilical vein, vitelline vein, cardinal vein on this side. Then you have vitelline vein and cardinal vein here. So you can yeah, so it's clear here you can appreciate the right vitelline vein and the left umbilical vein here. The right vitelline vein is here. This is the left vitelline, the left umbilical vein. Then the common cardinals are coming from this side. So what we're trying to say is each horn gives you a branch of the cardinal vein, umbilical vein, and the vitelline vein. But at the 4th week, the sinus venosus receives from both right and left horns. But when you get to the 5th week, there is obliteration of the right umbilical vein. So the right umbilical vein will obliterate as well as the left vitelline vein. So you are left with left umbilical vein and right vitelline vein. So this is now, you can appreciate the coronary sinus forming from the left horn, and here's the coronary sinus. It usually lies in the posterior atrioventricular groove. So at the 10th week, the left common cardinal vein usually obliterates. Then, how do you form adult left atrium? Most of the left atrium is smooth, unlike the right that has a rough part and a smooth part, okay? So the left atrium, most of it is smooth and is derived from, so most of the left atrium is smooth and is derived from the primitive pulmonary vein. And usually it develops as an outgrowth of the dorsal atrial wall to the left of the septum primum. So towards the left side of the septum primum, the dorsal atrial wall develops an outgrowth, and this is going to be the primitive pulmonary vein, and that forms the smooth part of the left atrium. Now, the primitive pulmonary vein and its branches are usually incorporated into the atrial wall. So eventually we have 4 veins that open into the left atrium, where 2 are from the right and 2 from the left pulmonary vessels. Then the left auricle arises from the primitive atrium. It's just an appendage of the primitive atrium, okay? So this just shows we have an atria and we've managed to partition it, and this is your sinoatrial orifice, and at this portion you can appreciate the sinus venerum has been incorporated into the right atrium, so it forms the smooth part of the right atrium, and then that's the crista terminalis that separates the smooth from the rough part that's made up of pectinati muscles. And then your septum secundum is here, meaning this is your foramen ovale, that's your septum primum, and you can see these are the openings of the pulmonary veins, and that means this is the part of the primitive atrium that forms from the pulmonary veins. So this is a cross-section of the heart showing the smooth part of the right atrium and the smooth part of the left atrium, and both the walls of the right sinus horn, that's in blue, and the pulmonary veins, that's in red, they've been incorporated to form the smooth parts of this atria. So the smooth part of the left atria is from the pulmonary veins being incorporated, and from the right atrium is from the sinus venerum. Then we need to partition the ventricle. This one is easy. So we have two parts of the interventricular septum. There's a muscular part and a membranous part. So for the muscular part, the base of the heart, from the base of the heart, you have a muscular ridge, yeah? A muscular ridge will develop at the base of the heart, and then it starts growing upwards. Then we usually have an interventricular foramen. This is between now the free edge of this ridge. Remember, the ridge is growing upwards towards the endocardial cushion. So between the free edge of this ridge and the endocardial cushion is the interventricular foramen. And this foramen usually permits communication between right and left ventricle until the 7th week. Now, the foramen, this interventricular foramen, usually closes after the fusion of the subendocardial tissue. Yeah, and the fusion of subendocardial tissue occurs from three sources. We have the right bulbar ridge, left bulbar ridge, and the fused atrioventricular septum. So when all these fuse, the interventricular foramen will fuse. Right bulbar, left bulbar ridge, and the fused atrioventricular septum. Then we have the membranous part of interventricular septum. This is usually derived from extensions from the right side of the fused atrioventricular endocardial cushions. Remember, we had our dorsal and ventral endocardial cushions that joined and fused. So from these endocardial cushions, we have tissue extensions from its right side that will develop, and these go downward and form the membranous part of the interventricular septum. But part of these tissue extensions can extend upwards and form the aorticopulmonary septum. This is the septum in the truncus arteriosus that tends to divide it into aorta and the pulmonary trunk. So tissue extensions from the right side of the endocardial cushions fuse with the aorticopulmonary septum and also the muscular part of the interventricular septum. And after the closure of the interventricular foramen, the aorta is in complete communication with the left ventricle, while the pulmonary trunk is in communication with the right ventricle, because aorta, from the left ventricle, blood is pumped to the rest of the body through the aorta, and from the right ventricle to the lungs through the pulmonary trunk. So this is how the ventricles are formed. You can see this ridge from the base, that's the muscular part, then this is the interventricular foramen, and we said it will close after fusion with the endocardial cushions, the left and the right bulbar ridges. So this is the foramen. Okay, so that's how the muscular interventricular septum is formed. And then for the membranous, from the endocardial cushion, you have tissue that will come down and fuse with the muscular part, and another one that will go up and form part of the aorticopulmonary septum. Now this just shows blood flow from right atrium through foramen ovale to the left atrium. And this is the aorticopulmonary septum that we have said is continuous with the membranous part of the interventricular septum. So the truncus arteriosus will develop a septum, okay? There will be a right and left conotruncal ridge, then the conotruncal septum will form, and there will be sort of twisting, and that's how you get the arc of the aorta over the pulmonary trunk, okay? So in the next video, we'll basically explain how this truncus arteriosus forms. Thank you very much.